So 2020, a cylindrical specimen of diameter 54.7 mm, length is given 1110 mm. A basalt, so linear elastic behavior under uniaxial compression. So at axial stress of 100 megapascal. So here stress is given, sigma is given 100 MPa. Which the measured axial strain. The strain is given in 0.2%. So we have to calculate the Young's modulus in GPA. So Young's modulus will be stress by strain. So 100 MPa divided by 0.2% will be 100 MPa divided by 0.002. Will be 50,000 MPa, which will be 50 GPa. Next question: a tip line of an actively propagating frost fault. So given is your frost fault. So frost fault is given. There is a depth of 1 kilometer. D is given 1 kilometer. From the horizontal ground surface, the average density of the material density is given 2700 kg per meter cube. The rock at this depth follows the failure criterion given by the equation. So it follows the given failure criterion. Sigma 1 is equal to 10 MPa plus 3 sigma 3. So we have to calculate the maximum principal stress, that we have to calculate the sigma 1. So G is given 10 meter per second square. So first we have to calculate either sigma 1 or sigma 3. If you calculate any of these, then you can put it in criterion. So here given frost fault, so that means sigma 3 is perpendicular to the ground or perpendicular, sigma 3 acted perpendicularly. So from that we can calculate the pressure. So here is given your density given, depth given, G given. So we can calculate sigma 3 by applying rho G's formula. So sigma 3 will be 1 kilometer into 2700 kg per meter cube into 10 meter per second square. Okay, sigma 3, what will the value of sigma 3? It will be 27 MPa. Now put the sigma 3 in the criterion, you will find sigma 1. So sigma 1 equal to 10 MPa plus 27 into 3 MPa. It will be 91 MPa. During a rock slide, a 20 kg granite block gets dislodged from the top of the planar hill slopes and start sliding down the slope. The slope angle is given 30 degree. So after traveling a distance of 40 meter in the same direction, there it is given 40 meter. So you have to calculate the velocity. The velocity with which the block hits the road. So you can use the formula v square minus u square equal to 2a s. So s is given 40 meter. So here this will be the acceleration due to gravity. In this direction I am saying this is g. So this will be g cos theta, and in this direction it will be g sin theta. It is an angle. So g sin 30 will be the acceleration. So v square, where initially it will be in rest condition, so u will be 0. V square equal to 2, then a will become g sin theta. G, that is given 10 meter per second square. So 10 meter per second square into sin 30 degree into 40 meter. So sin 30 will be 1 by 2. This 2 into 10 into 1 by 2 into 40. So 2 will be cancelled, will be meter square per second square. With 400 meter square per second square. So V will be root over of 400 meter per second, which will be 20 meter per. So the apparent deep amount of a sandstone bed it is 45 degree. So apparent deep it is given alpha is given 45 degree. The angle between the true deep direction and apparent deep direction. So angle between true deep direction and apparent deep direction is your beta. It is given 60 degree. So you have to calculate the true deep amount of the bed. So you have to calculate theta. Tan alpha equal to tan theta into cos beta. So tan theta will be tan 45 degree divided by cos 60. Theta will be 63.4. When vertical borehole encounters a shale bed of uniform thickness occurring at a depth of 5 meter and deeping 60 degree. So bed is deeping 60 degree like this. The vertical borehole encounters shale bed uniform thickness. So we will insert a vertical borehole like this, and the shale bed, the borehole pierces through this shale bed for a length of 10 meter. So it pierces through the bed length of 10 meter. This is given 10 meter. So the true thickness of the shale bed. So we have to calculate the true thickness. This is the true thickness of the shale bed. So this will become vertical thickness. Okay. So we have formula: true thickness equal to vertical thickness into cos theta. So true thickness you have to calculate. Vertical thickness is given 10 meter and theta is given 60 cos 60. So it will be 5 meter. True thickness will be 5 meter. In a zone of active normal faulting, the maximum and minimum in situ principal stress given 30 MPa. Sigma 1 it is given 30 MPa. Sigma 2 it is given 10 MPa. So fault plane striking north south has a deep amount of 60 degree. So suppose if this is the fault plane, so this angle is 60 degree. So this will be sigma 1, will be sigma 1, this will be sigma n. So this angle will be your theta. Okay. So if this 60, this will be also theta will be also 60. You can calculate this 60, it will be 30, and this angle is 90. Then theta will be 60. So sigma n will be sigma 1 plus sigma 2, that is sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 cos 2 theta. 30 plus 10 divided by 2 plus 30 minus 10 divided by 2 into cos 150 degree. 20 plus it will become minus 5 to 15 MPa. So strike and deep of the axial plane of a reclined fold. So you have a reclined fold. So the strike and deep of the axial plane is given. So the attitude of the axial plane you can say it is given. Strike is given 0.22 degree, and deep amount and direction it is 20 degree southeast. So in a reclined fold, the fold axis plunges in the deep direction of the axial plane. In the deep direction of the axial plane. So we have to find out the deep direction of axial plane, that will be the plunge direction of the fold axis. So strike is given how much? 0.22 degree. It will be like this. It will be 0.22 degree. So perpendicular to it will be your strike direction. There is a deep direction. So it is 2 deep direction. It is strike direction. It is 22 degree. This one will be 90 minus 22. This will be 68. Again, this is 90 degrees. So this will be 22. This will be 22. So we have to calculate the direction in terms of bearing. So this much will be the bearing angle. So we have to calculate from the north. So this much will be the bearing angle. Okay. So this is up to this will be 90 plus 20. It will be 112. So this will be the true deep direction of the axial plane, and this will be the direction of the fold axis. Because in the reclined fold, the fold axis plunges in the direction of the axial plane. So both have same direction. So the answer will be 1, 1. The sandstone follows Mohr's Coulomb failure criterion if the uniaxial compressive strength and the angle of internal friction, that is phi, is given 30 degree. If the uniaxial compressive strength, that is given 7 MPa, that is given 7 MPa. So uniaxial compressive strength means that the sigma 1 is given 7 MPa, then sigma 3 will be 0 because it is uniaxial. So we have to calculate the cohesion. We have to calculate the C. So you will apply this Mohr failure criterion. Sigma 1 is equal to sigma 3 tan square theta plus 2c tan theta. So we know the relation between theta and phi. Theta is equal to 45 plus phi by 2. So phi is given. We'll find out theta. You can find out theta. So then sigma 3 is 0. So for uniaxial compressive strength, it will become sigma 1 equal to 2c tan theta. So find out the theta here from this formula. Then sigma is given. You can easily calculate c. Where sigma is given, sigma 1 is given 7 MPa. So you can say 7 MPa 2 into c into tan 60 degree, because phi is 30, so 30 by 2 plus 45 will be 60 degree. So c will be 2.0. At certain depth the crust, the maximum and minimum principal compressive stresses are 150 MPa and 75 MPa respectively, which lead to a normal fatigue. So here this normal fatigue indicating that sigma 1 is vertical. So sigma 1 will be 150 MPa. Okay. So the average density is given 2700 kg per meter cube. The crustal depth of the fracture initiation. So I have to find out the D. So G is given 10 meter per second square. Sigma 1 will be rho GH, rho G into D. So we have to calculate the depth. It will be sigma 1 divided by rho G. So sigma 1 is given 150 MPa divided by 2700 into 10. So just convert the MPa into Pascal. 10 to the 6 Pascal divided by 2700 into 10 will be in meter. will be 5.55 meter, which will be answer is asked in kilometer, so 5.5 kilometer. So cylindrical sample of granite, diameter given, length given, so linear relations between axial stress and strain under uniaxial compression. So the same type of question again repeated. The compressive strength is given, sigma is given 200 MPa and strain is given 0.005. So we have to calculate Young's modulus, sigma by E 200 MPa divided by 0.005 to 40,000 MPa will be 40 GP. So answer will be 40 GP. So the in situ stress at a point of a dry sandstone terrain is as follows. The sigma 1 is given 12 MPa, sigma 3 is given 4 MPa. So the pore water pressure increased by the construction of reservoir. So when pore water pressure increased, the failure criterion of the sandstone it is given by failure criterion is given by sigma 1 dash is equal to 3.48 MPa plus 3 sigma 3 dash. So sigma 1 dash and sigma 3 dash are effective maximum minimum pressure. So how we will find the effective pressure? So it will be sigma 1 is given 12 MPa, sigma 3 is 4 MPa. So pore water pressure, I have to subtract this. So sigma 1 dash it will be sigma 1 minus pore water pressure, and sigma 3 dash it will be sigma 3 minus pore water pressure. Now we can put this thing on this criterion, you will get your answer. So it will be your 12 minus pore water, it will be 4 minus pore water. So we will put this 12 minus pore water will be equal to 3.48 plus 3 into 4 minus 4 water. So if we solve this, the pore water pressure will be 1.72 MPa. 1.74 MPa. Come to MCQ question. Which one of the following list only kinematic parameters? Kinematic parameters means it does not involve any stress. It does not involve any stress. So stress is not included. Here on other condition, force or stress are included. So those are dynamic parameters. Force or if stress are stress, strain, force, those are dynamic parameters. So as stress and force are not included, that is your kinematic parameter. That is your translation, rotation, distortion. So this is your kinematic parameter. Answer will be B. Then the plunge of the normal to the axial planes of a vertical and upright fold is. So this is a vertical fold. Suppose this is a vertical fold and this is an upright. Okay. So this will be the axial plane of vertical fold, and this will be the axial plane of upright. So it is saying the plunge of the normal to the axial plane. If you draw any line that is perpendicular to the plane of the axial, that is perpendicular to the axial plane. So any line that is perpendicular to the axial plane in case of vertical fold or upright fold will be horizontal. So now see, this is horizontal. So if this is vertical, then this line will be horizontal. So if it is a horizontal line, then the plunge will be 0. So the plunge of the normal to the axial planes of vertical and upright fold, it will be 0 degree. Then a thrust part exhibiting ramp and flat geometry, which one of the following pair defines a flat? So flat is said when the deep of the fault plane and bedding deep, they are in the same direction and same amount. So that means the deep of the fault plane and bedding deep are same both in direction and amount. So here only this that indicates the fault plane deep 60° north and bedding deep also 60° north. So that will be parallel. So in this condition they are considered as flat. Flat is not always horizontal. It is on the basis of bedding. If the fault plane is parallel to the bedding, then it will be considered as flat. The answer will be IV with D. So the base develop lineation and collision traces in LH tectonics. So always remember, so to observe a collision lineation in LH tectonics, you have to choose a plane that should be perpendicular to the collision but parallel to the lineation. You have to choose a plane that should be perpendicular to the collision but parallel to the lineation. So this is the best section to study relation collision in LH tectonics. Next, also in the given diagram, which of the combination is correctly defines structural types. So this is Strysley setting, this is contractional, this is extensional. So contractional means you will get reverse fault, extensional you will get normal fault, and contractional and Strysley combinedly they can be called as transpressor, and extension and Strysley combinedly called as transtension. So if you see in transpression you will get pressure ridge, and in transtension you will get pull apart basin. Then in contractional you will get thrust or reverse fault, and in extension you will get normal fault or host. So this should be correct also. So I pressure is it is transpression, pull apart basin, transtension, then compression it is thrust, then extension it is host. The given stereo plot of the axial plane and axis of the fold. So fold axis at the periphery, axial plane is also coincide with the periphery, so both are indicating horizontal condition. So if both are horizontal, it will be a recombinant fold. Where axial plane and fold axis is horizontal, it will be recombinant. If the orthogonal thickness is constant along the folded layer as per Ramsey classification, if the orthogonal thickness is constant, so that is called as your parallel fold. Parallel fold. So in Ramsey classification, class 1B your parallel fold. The answer will be class 1. And remember class 2 it is similar fold. Similar fold. So there are three types of classification according to Ramsey: class 1, class 2, class 3. So class 1 is your converging axial plane or deep isogon. Then class 2 parallel deep isogon. Class 3 diverging deep isogon. Then with regard to superposed folding, the stereography projection represent of a geometry. Here stereography projection, here we have axial plane that is perpendicular, so it will be plane. And here fold axis is given, that is simple plunging. Only fold axis are not plunging. This is also F1, this is also F1. The same fold axis is here. That is simple plunging. So that means it is cylindrical. It can be cylindrical. So it will be plane cylindrical. So in the given outflow pattern, bed that is given shaded with respect to the contour. So here the contour they represent a V shape and they deflect towards the higher elevation. The contour indicates ratio value. Then the bed is also deflecting towards the higher elevation, it produces a V shape pattern. So it can dip upstream. So if the bed are dipping upstream in a valley, it will produce a V and V will point towards the upstream. So when the bed is dipping upstream, the answer will be A. If it is horizontal, it should follow the contour. As it is intersecting the contour, it will not be horizontal. Deep steeply downstream, if the bed dipping downstream, then the B should will point downstream. So as B points upstream, so it will be towards upstream. Deep downstream at an angle equal to the valley gradient. If this will be the condition, then there should be no V. So that's why answer will be A. Which one of the following is a typical product of ductile deformation? So these are all breccia, cataclysite. These are formed in brittle deformation. Myeloid it is indicating ductile deformation. They are found in shear zone. These are shear zone rocks. The Poisson ratio of an incompressible liquid it will be 0.5. Then the Hocken-Brown failure envelope is typical the segment of which one of the following. So Hocken-Brown is another failure criterion, which also has a segment of parabola. So it produces a parabola. Like your Griffith's fracture criterion, Hocken-Brown criterion will also produce a parabola. The relationship between conjugate shear fracture and the principal stresses in a homogeneous isotropic deformed body is shown in the stereo plot. Sigma 1, sigma 2, sigma 3 are compressive. So here in this diagram you can clearly see sigma 3 is vertical. So when sigma 3 is vertical it will be a reverse part or frost condition. So here given reverse, the answer will be reverse. On a fault surface with strike tip given, the strike is given 320, understood? So true dip direction will be towards 050 because it is given towards northeast. So true dip direction it is towards northeast. It will be 050 or 50 degree, north 50 degree east. So any line should be plunged in that direction will have a debug equal to true dip. So here 55 degree 050 will be the correct one because 050 is the true dip direction. So any line plunges in that direction will have a dip of 55 degree. In 320 direction, it will be the strike direction, so the dip will be 0 to be correct. And 325, it is very close to the strike, so dip should not be 50, it will be less than 50. And 60 degree cannot be the plunge because the true dip is 55 degree. Which type of porphyroblast listed below is are suitable as a kinematic indicators in ductile shear? It is a MSc question. The sigma type and del type you can use. Theta and phi, these are symmetrical structure, they cannot be used. So answer will be sigma type and del type. With this stereo plot, you can see fold axis is perpendicular or vertical. You can say axial plane is also vertical. So if both are vertical, you can say those are vertical. The deep direction of the lee side of a straight casted ripple. So we have a straight casted ripple here. So this is the lee side. This is the lee side. This is stoss side. So the deep direction of the lee side is given found to be 15 degree, and the direction is given north 10 degree west. North 10 degree west. So consider the unique directional water movement, the flow direction of the it will be which direction. So if this is stoss side, lee side, the flow direction will be this direction. So the lee dipping direction will be the flow direction. So that's why the answer will be north 10 degree west. The given outflow pattern of a flat topography represents. So here the fold axis plunges towards each other. So if in that condition it will be a depression. It will be a depression, and the outflow plunges opposite to the plunging direction. So it will be a synform. So it will be synform with axial depression. The symmetric cross section of a hill and planar discontinuity. This is hill and this is discontinuity. Intersect a plane planar slope. So using kinematic analysis, which of the following condition favors plane failure to occur? So first is the deep of the discontinuity surface is less than the slope surface. If the deep of the discontinuity, it will be less than the slope surface. So it will favors the slope failure because more steeper condition is a stable condition. The friction angle of the discontinuity surface is more. If the friction angle of the discontinuity surface is more, then there will be no slippage or no failure. So it will be incorrect. So friction angle on discontinuity surface is less. So friction angle is if less, then failure can occur. And the deep direction of the both is if same, that also the favors the failure condition. So ACD will favors the failure condition. So the following rock structure is are folds. So antiform, syncline, synform. These are fold structure. First is a fault, normal fault. So which of the following lineation can be observed on a position of altitude 210 40 degree northwest? The same question we have to find out the strike direction here. So it is given 210. Approximately will be this will be 210. This will be strike direction. Then we have towards northwest. We have our true dip direction. This is true dip direction. If it is 210, it will be 30. Will be 60. Will be 30. 30 means the attitude, the bearing will be here. So up to direction will be 300. So this will be 270 plus 30, 300. So 300 will be the true dip direction. So in this direction, the attitude of lineation, first thing it should not exceed 40 degree. If it will exceed 40 degree, then it will be incorrect because true dip amount is 40 degree. Then 40 degree towards 300 it will be correct because 300 is the true dip direction. In that direction the dip amount will be, the plunge amount will be the dip amount. Then 40 degree towards 040, 040 will not the direction of dip direction. 40 degree 220, 220 it is very, you can say close to 210. So that is the strike direction. So 40 degree will not be dip. 40 degree towards 350. So 350 it is also not true dip direction, so the angle will not be 40. So only 40 degree will be in the true dip direction. So that is your 300 direction. Okay, the answer will be A. Which are the following structure these are associated with duplexes in cold frost belt? So it will be roof thrust, floor thrust, horses. These are the structure that are associated with duplex in cold frost belt. Which of the following represent the deviatory stress in a 2D Mohr circle? So deviatory stress it will represent by the radius. So deviatory stress means stress, the mean stress minus stress. So mean stress will be sigma 1 plus sigma 3 by 2. So this will indicate the mean stress. If you divide sigma 3 from mean stress, you will get this much thing. This is the radius. So deviatory stress in 2D Mohr circle that represented by radius. The fold profile section shown here in the figure 1 and 3 are the oldest and youngest respectively. 1 is the oldest and 3 is the youngest. Which are the following expression correctly match? First thing, this thing it is an antiform. It is an antiform. It is closest upward. And it faces towards, you can say, west. So age relationship is not required here. So it is simple. We can say an antiform that facing west. So antiform facing west. Which of the following statement is correct? These are correct for the M plane of the fault. So M plane is a plane that perpendicular to the fault plane, you can say. So here it is given M plane pole of fault. So you have to remember this thing. So M plane pole of a fault is located on the fault plane. It is correct. M plane pole of fault, it is perpendicular to the slicken line of the fault plane. So actually this it is parallel to the fault plane if the only M plane it is parallel to the slicken line, but the pole of the M plane it is perpendicular to the slicken line. And the M plane pole of fault is perpendicular to the pole of the fault plane. So this is a plane. This is called as M plane which is perpendicular to this fault plane and it will parallel to the slicken line. But here in question it is talking about the pole of the plane. So you have to represent it in stereo representation. So the pole of this plane, it should be perpendicular. If it is perpendicular to the plane, the pole will be perpendicular to the fault plane. So this is your M plane of a fault. Here A, B, D. These three options will be correct, and you just remember this is about the M plane. These are characteristic of pole of M plane of a fault.